Assalamualaikum and hi everyone. We are now in lecture 8, Distributed Database Management Systems, DBMS, part 4. At the end of this lesson, you should be able to explain the horizontal, vertical, mixed and derived fragmentation together with its correctness rules.
So before we go further to distributed database design, let's summarize a little bit on the DBMS concept. Okay, so in a normal database approach, we will have multiple users who will use DBMS to access the database. However, in a company might have few branches all over places or all over location. For example, we have one branch in KL, one branch in London, another branch is in New York, and the last one maybe in somewhere, let's say Manila. Okay, so let's say your company have these four branches, and these branches can be connected through a communication network. Okay, so these branches is connected through a network. So since the headquarters is in London, so the London branch may have the database. So if you are from KL, you want data from the database, you need to go through the communication network and go to the London branch to get to the data. So this is the concept of centralized database, where database is only reside at one node of a computer network. Okay, so by right, if you are in New York, if you are the user here, then you need to go to the communication network also to get the data from the database in London. Okay, so however, this one we say that central database has so many problems. Okay, there are a lot of problems of central database. The main problem is, let's say, if the site that holds database down, okay, if the site that holds database down, then it will be no data access. No data access. Okay, because why? If the site here down, then people in New York, people in KL, and people in Manila cannot access the database at all. So of course, there's no problem. There's no work can be done because you need data from the database to operate your business. Okay, so other than that, maybe we can say also reliability problems. Okay, because if this user using data A already here, then if you want to use A, you have to wait for people in Manila to finish first. Okay, then other than that, we can say bottleneck. Okay, what does it mean by bottleneck here? Bottleneck means if there are too many users access the database at the same time, then the line here will be congested. Okay, so that's what we call as bottleneck. Okay, so since there are a lot of other problems that we have discussed previously in the lecture part 1, okay, so that's why they introduced the concept of distributed database. What does it mean here? So this is your database. Okay, this is your database here. Okay, so this is your database. What you are going to do is you divide this database into few parts. Okay, you divide database into these few parts. This is what we call as the concept of fragmentation. Okay, process of dividing database into few parts. Let's say you divide database, and normally we will give our fragment a name. So I give this is as A, this is as B, and this is as C. So from one big database now, you have divide into A, you have divide into B, and you have divide into C. Okay, so this is your take this one is your relation. Okay, so this is now it has become A, B, and C. Okay, so you divide your relation or your table into few parts. So that's the concept of fragmentation. The second concept, maybe you can do a replication. Okay, replication. For example, since the other user also want to use C the most, so what we can do, we replicate C. So this is what we call as data replication. This is replicas. Okay, replica. Okay, then the third concept is allocation. where do we want to put the data? Okay, allocation means where do we want to put data? Data allocation will be on the greatest demand. Okay, be on greatest demand. For example now, okay, so this is your network. Okay, so this is your branches now. We have KL, we have New York, we have London, and also we have Manila, for example. Okay, so what if we say that London want to use A and B the most, so we give A and B at London. New York want to use C the most, so we give C to New York. And at the same time, and since we have only three different fragments, isn't it? So we have done A, B, and C. Okay, we have put the fragments at greatest demand. Okay, so since London want to use A and B the most, and you want to use C, so we give that particular fragment to that particular branch. Okay. However, what if you say that since we have a replica, Kuala Lumpur also wants to use C the most. So what we can do, we can replicate data fragment C and give to Kuala Lumpur. So this is the replica. So if you update the copy, you need to update also the replica. Okay, so it must be the same. That's why we call it replication. Okay, it must be totally the same. And not every site, if you take a look, Manila has no database, isn't it? Has no fragment, isn't it? On its sites. It's okay because not every single site or every single branch need a database. So it means this Manila can access the other fragments from the other branches. It can go to London, KL, or New York to get to the data. Okay. However, now people in London doesn't need to travel all over the network anymore. Same goes with people in KL. It doesn't have to go to the network to go to the London branch to get the data. Okay, because now they want to use C and we give the replica of C to its sites the most. So now all operations of KL will be done on its sites only because we give the the replication over there. Same goes with New York. Okay, people in New York, doesn't need to travel all over the network. Okay, the data doesn't to travel all over the network and request data from London branch anymore because the data that they want the most is C, so they have the C already over its own site. Okay, so that's the concept of fragmentation. Distributed database actually. Okay, the fragmentation, replication, and allocation. Okay, you have one big table over here. Okay, you have one big table over here. From this one big table, if you do central database, we will have these problems. Okay, we will have this problem. Okay, so what we can do, we can use the concept of distributed database. What does it mean here? We have one big table, we divide into few parts. So that's what we call as fragmentation. Okay, what kind of fragmentation that you want to do is up to you. It's either horizontal, vertical, mix, or derived horizontal fragmentation. Okay, after this we will take a look. Okay, we will take a look at these four types of fragmentation. Okay, however, let's say we divide into this part. We have fragment A, fragment B, and fragment C. Okay, so this is what we call as fragment. Okay, fragmentation, we divide the database into few parts. Then if you need a replication, you can do data replication. Means you copy exactly the fragment that you want to have. Okay, and the last one you consider about allocation. Okay, allocation means where do you want to put the data or where do you want to put the fragment. Of course, it will be at greatest demand. Okay, let's say people in London want to use A and B. Why do we want to give C to London? So give A and B to London. So that's how it works, okay, for allocation. So I hope you get, this is the basic concept of distributed database design. We have centralized database, horizontal database, we have problems, then we do three different concept of distributed database, which is fragmentation, replication, or allocation. If you don't want to do replication, so there's no problem. If you think that there's no need of replication, then of course you doesn't need to do any replication. So let's take a look on the case study. Okay, so when you get the case study, normally you will be given the relational schema or some sample data over here. Okay, some sample data over here. So if you are given this one, the first thing that you do is please draft the ERD. Okay, please draft the ERD first. So we have table employees, assignment, project, and pay. So you know that which one is the bridge assignment. Why assignment is the bridge? Because it has the employee number and it has the project number. So now we know that employee is attached to assignment. Okay, and assignment is attached to project. Okay, then we know that the bridge will always have many sides. Okay, one project, one employee, many assignment, one project will be listed also in many assignment. Then we have table P over here. Take a look, we have title and title over here. So this is the PK and this is the FK. So now employee is attached to pay. Okay, employee is attached to pay. One pay will be assigned to many employees because employee has the foreign key. Okay, so once you have the draft for the ERD, please determine which one is the parent, which one is the child. The one that have foreign key will always be the child. So the pay is the parent, employee is the child. This one has the foreign key, assignment has foreign key, employee is the parent, assignment is the child. And for project is the parent and assignment is the child. Okay, so after you get this one, then you can move on to the question. So let's take a look on our question here. Okay, do a horizontal fragmentation. Horizontal fragmentation, you need to use sigma. Okay, based on project 1, projects with budget less than 200k. Project 2, projects with budget greater than or equals to 200k. So now you want to work with project. So table project over here. Okay, so this is the fragment name. We have two different fragments. Project 1, and we have project 2 over here. Okay, in project 1, what do you want? Okay, horizontal fragmentation, you want to divide the row. Okay, you want to divide the row. Project with budget less than 200k. So which column do we need to take a look at? Project, column budget. So what do we select? Budget less than 200k from which table or from which relation? Project. Okay, and the second one, projects with budget greater than or equals to 200k. So the same thing, we select budget greater than or equals to 200k. Okay, 200k from which table? Project. So after you have these two fragments, if you take a look in project 1, take a look P1, where P1 will go? Project 1 or project 2? P1 will go, since budget less than 200k, will go to P1, project 1, Prosh 1. This one 135k, Prosh 1. This one 250k, Prosh 2. This one Prosh 2. So that's why in the end, in our fragments, after we have divided according to this relational algebra, we will get in project 1, P1 and P2, in project 2, P3 and P4. Since we divide the row, take a look, number of columns for each fragment will be the same. P number, P name, budget, location. P number, P name, budget, location. Because we divide the row. Okay, so we divide the row, we get all the same schema. However, the data will be different. Two data over here and two data over here. Okay, depends on how many data you have inside your database. Okay, this is just an example. Supposedly, it will be more data. Okay, however, if you take a look here, based on this one, the one big table project has been divided into fragment Prosh 1, fragment Prosh 2. Okay, and this is the relational algebra to divide the table into smaller fragments. Okay, so you need to understand also, once you have divided the data, this data can be combined back to become one big table. Okay, just now we have this one is two data, this one is two data. How can we combine back so that we will have all of the data inside the same fragment again, inside one big project again? So to reconstruct this one, we will use union operation. Since they have the same schema, we can do union operation. Project 1 union with project 2. Okay, project 1 union with project 2. Then you have 4 data all over again as one big table. So this is the reconstruction. Okay, as I say, you need to remember, after you have done the fragmentation, you can also combine back all the fragments to become one big table again. So how to combine the horizontal fragmentation? We will use union operation. So now the data will be in one big project table again. Okay, so if you have, because two data coming from project 1 and two data coming from project 2. So if we union this one, we will get 4 data in one big project table again. Let's continue with the second question. Okay, for the second question, do a vertical fragmentation. Vertical fragmentation will use pi. Okay, based on this, project 3, information about project budgets. Project 4, information about project names and its location. So now when we talk about vertical fragmentation, you want to divide a column. Okay, but first, please determine what is the PK of this project. The PK is P number. So you need to know that the primary key will always be at all of the fragments. So now how many fragments do we have? Project 3 and project 4. Okay, the first thing, put the symbol for vertical fragmentation, which is pi. Okay, and the first one, put the primary key, project number and project number. So primary key must be at all of the fragment. After this, I will show you why we need the primary key at all of the fragment. So the first one, project 3, information about budget. So which one is budget? Here. Okay, budget. So we want P number and column budget only from which table? Project. Okay, the relation name is project. Okay, and the second one, information about project names and location. So names and location. So second one, we want project name, P name, and location. All this coming from which table? Project. Okay, so if you take a look, based on our project 3 fragment, we will have this one, P number and budget. So you take all the data into the fragment. Same goes the second one. We want P number, P name, project name, and location. Okay, so this is the fragment for project 4. Okay, this is the fragment for project 3. So you just divide the column. Okay, the number of row for all of the vertical fragmentation will be the same. Okay, just now in the horizontal fragmentation, the number of columns must be the same because you divide the row. Now you divide the column, only the column will be divided into few parts. The row is still the same. Okay, so as I said, you have project 3 and project 4. Okay, you have two different fragments. So how can you reconstruct back? Okay, how can you reconstruct back so that it will become one big table again? Project 3 plus project 4, you will get one big project table again. So what can you do? Project 3 and project 4. The reconstruction for vertical fragmentation, the symbol is join. Okay, project 3 will join with project 4 on what is the common attribute? P number. So that's why the primary key must be at all of the fragments so that if you want to do reconstruction, it will be based on the primary key. Okay, so this is the project number. Okay, so if you reconstruct back the table, you will get back one big table with all of the columns. We have P number, budget, P name, and location again in our table. So this is for vertical fragmentation. In this example, they ask you to do a mixed fragmentation. So if you take a look, you want to do mixed fragmentation based on project 1 and 3, information about project budgets, and it must be less than 200k. 1 and 4, information about project names and its location, and it must be less than 200k. And information about project 2 and 3, information about project budgets, and it must be greater than or equal to 200k. And project 2 and 4, information about project names and its location, and it must be greater than or equals to 200k. So if you take a look, you have 4 different fragments that you want to do. Okay, 4 different fragments. Remember, mixed fragmentation, you need to use pi and also sigma. It is a combination of vertical and horizontal fragmentation. Okay, so let's take a look on the first one first. Project 1 and 3. So this is the fragment name. Okay, information about project budgets. So we only select project, P number and budget. Okay, P number and budget, and it must be less than 200k. So we select budget less than 200k from which table? Project. So you do mixed fragmentation over here. Okay, the projection and selection. Then the second one, project 1 and 4. Information about project names and its location. Okay, just now we have to P number, P name, and location. And what do you select? Budget less than 200k from which table? From which relation? Project. Okay, so this is for the second one. And for the third one, project 2 and 3. Information about project budgets. P number and budget. And you need to select budget greater than or equals to 200k from table project. Okay, same goes with project 2 and 4, which is 1, P number, name and location, P name, and location. What you want to select? Budget greater than or equals to 200k from relation project. Okay, so we have done all of these 4 fragments. So if you take a look, from one big table project, now we have 4 different fragments. The first one, P number and budget. The second one, P number, P name, location for budget less than 200k. 2 and 3, the P number and budget for budget greater than 200k. And project 2 and 4 here, for P number, P name, and location for budget greater than or equals to 200k. So this is what we call as mixed fragmentation, as we combine the vertical and horizontal fragmentation. Okay, just now we know that horizontal fragmentation, if we want to reconstruct, we use union. For vertical fragmentation, if you want to reconstruct, we use joint operation. So how can we reconstruct back these 4 fragments to become one big table again? Okay, how can we reconstruct this one? Okay, so the first one, let's combine. Okay, let's combine P1 and P3. Sorry, P13 and P14, and we combine P23 and P24. So this one is for the table with budget less than 200k. This one for fragment with budget greater than 200k. So what can we do? How to combine this one? So this is the same thing, isn't it? 200k, 200k. So we have to combine this one to become one big table again. So what can we do? Okay, what can we do to reconstruct this one? Okay, the first one, what can we do? We do joint operation. 1 and 3 join with project 1 and 4. Okay, so on P number. So if you do this one, what you will get? You will get P number, P name, budget, and location for budget less than 200k. Okay, then the second one, what can we do? Project 2 and 3, you join with project 2 and 4 on project number. So what will you get also? You will have 4 columns, P number, P name, location, and budget and location. So now this one is for budget greater than 200k. So now the schema is the same, 4 columns. Okay, 4 columns. Then what can we do? We use union operation. Okay, union operation for these two relational algebra. Then after you combine all of this, then you have one big table project again. So all of data will be inside here. So this is the reconstruction for mixed fragmentation. So let's continue with the next question. Okay, do a horizontal fragmentation based on, so we want to do horizontal. Horizontal means we need to use sigma. Pay 1 salary less than 330k. Pay 2 salary greater than, I forget to add greater than or equals to 30,000 30k. Okay, so we have two different fragments here. Pay 1, so we want to select salary less than 30k from which table? Pay. Okay, and the second one we have pay 2, we select salary greater than or equals to 30k from pay. Okay, so if you take a look now, for the first, as I said, horizontal, we divide the row. When you divide the row, then you will have the same schema. Okay, the same column, number of column, title, salary. The first one, salary less than 30k. The second one, salary greater than 30k, greater than or equals to 30k. So this is the fragments that we have, pay 1 and pay 2. How can we reconstruct back? Okay, how can we reconstruct back? Pay 1 union with pay 2. So this is horizontal fragmentation. Okay, horizontal fragmentation, we use union. So if you combine pay 1 and pay 2, union pay 1 and pay 2, you will get back one big pay table again. So let's take a look on question 5. Identify which table is a child table to pay table. Okay, so if we take a look on our ERD draft here, okay, which table is a child table to pay? Pay is the parent, employee is the child. So we can say here, the child table to pay is employees table. Okay, employee table. So this is very much related to question number 6. After this, we'll take a look at question number 6. So now let's take a look on question number 6. Do a derived fragmentation of an employee table. Okay, of an employee table. So now we want to have employee 1, employee with salary less than 30k, and we have employee 2, employee with salary greater than or equals to 30k. So just now we have done the pay horizontal fragmentation. Okay, salary less than 30k is what? Is pay 1. Okay, then if you take a look here, salary greater than or equals to 30k is pay 2 over here. Okay, so what can we do? We can do derived horizontal fragmentation. Derived horizontal fragmentation will use semi-join. Okay, we will use semi-join. Okay, so what do we want over here? We want employee. So we want all table employees derived with salary less than 30k. What is it less than 30k? Pay 1. Okay, pay 1. So what is the join condition here? Title. Okay, take a look, we have title over here and we have title over here. Okay, sorry, title over here. So employee derived with pay 1. Then the second one, what do you want? Employees. Employees with salary greater than or equal to 30k. It is pay 2. Okay, salary derived with pay 2 on title. So you need to remember that since employee is the child of table pay over here, okay, pay is the parent over here, then we need to use derived horizontal fragmentation, means double horizontal. This is horizontal fragmentation, this one is another horizontal fragmentation. So that's why we call as double horizontal fragmentation. Horizontal fragmentation first on the parent, the second horizontal fragmentation is on the child. So the derived horizontal fragmentation is based on the semi-join symbol over here. Okay, so now if you take a look, this is employees with salary less than 30k. This is employees employee 2, which is employees with salary greater than or equals to 30k. So this is what we call as derived horizontal fragmentation. We will use semi-join. Okay, so how can we reconstruct back? So since it's derived horizontal fragmentation, we do use union operation. So if you union employee 1 union with employee 2, then we will have one big employee table again, because the schema is the same: employee number, employee name, title. employee number, employee name, title. So since the columns are the same, we can use union operation. So employee 1 union with employee 2, we will have one big employee table again. Okay, so this is the concept of derived horizontal fragmentation. You do horizontal fragmentation on the parent, then the second one, horizontal fragmentation on the child over here. Okay, the child table. Okay, employee is the child table. So that's why in question 5, we determine which table is the child table of pay, because we want to do the example of derived horizontal fragmentation. So after you have done all of your fragmentation, you need to check for the correctness rules to make sure that your fragmentation is correct. Okay, so the first correctness rule that we have is completeness. What does it mean by completeness here? Each data item must be in a fragment. Okay, each data item must be in a fragment. So if you take a look, we have 4 different data over P1, P2, P3, and P4. And each and every data must have their own fragment. Take a look, P1 is at Proch 1, P2 is at Proch 2, P3 and P4 is at, P2 at Proch 1, and P3 and P2 at Proch 2 at project 2. Okay, so means each and every data item in your table must be in a fragment. If not, then the fragmentation rules might be wrong. Okay, the second one, reconstruction. Okay, so what does it by reconstruction over here? It must be possible to define a relational algebra that will reconstruct from the fragments. So it means you can combine back your fragmentation. Okay, you can combine back your fragments to become one big table again. So that's reconstruction. Okay, for horizontal fragmentation, we will use union. For vertical, we will use join operation. Okay, then the last one is disjoiners. Okay, what does it mean by disjoiners is if the data item is appear at one fragment, it cannot be appear at another fragment. Okay, one data item at one fragment only. Okay, so if you take a look here, P1. P1 is inside project number 1. It cannot appear on project number 2. It will be wrong. Okay, because the rules for project number 1, budget less than 200k. So of course it cannot be appear in another fragment. This one is not applied to the primary key. Okay, remember in our question number 2 here, primary key can be in both fragment. That's okay. Okay, that's the rule for vertical fragmentation. However, the data other than primary key cannot be in other fragment. Take a look, budget is only at project 3. Project name and location is not primary key. It can only be at project number 4. Okay, so the fragment should not appear. The data item cannot appear in another data fragment. Okay, for example, let's say I say that please divide yourself. Okay, please divide yourself according to your birthplace. Okay, your birthplace. Okay, so let's say I put here Sarawak and Pahang and Selangor, for example. So if you are born in Sarawak, you cannot appear in Pahang fragment anymore because it is illogical for you to be born at 2 different places, right? Okay, so that's what we call as disjoiners. If you appear at data item 1, you cannot appear in data item 2. This one is not applied to uh, primary key for vertical fragmentation. Okay, so this is what we call as correctness rules to make sure that your fragmentation rules are correct.
So I guess that's all for now. See you again in the next part. Thank you.